Hello and welcome to the next section of Unit 12. All right, so this section we're going to start off with some vocabulary. This section is all about just getting more into depth of tangent lines, but we're going to also talk about some vocabulary. So the first little description is a set of all points on a plane that are equidistant from a given point called the center of the circle. So this is just a circle. So this is kind of a weird definition, but they're going for a circle. So it's just saying we got a point and then a bunch of points that are all the same distance going around it. The next word, a segment from the center of the circle to any point on the circle. So from the center of the circle to any point is called a radius. A segment whose endpoints are on the circle. So it's a segment, for example, this right here, segment whose endpoints are on the circle, that would be a chord. A blank is a chord that contains the center. So if we have a chord, so you have two endpoints on the circle, and it goes through the middle, that would be called a diameter. And instead of a segment, if you have a line that goes through the circle, there's none on here, this one right here. So that means it doesn't just stop on the outsides of the circle, it keeps on going forever. That is called a secant. And that's not something you're going to have to really worry about this year, but just so you're aware of what it is, it's a secant line that goes through this all the way through the circle and keeps going. And then finally, a line in the plane of the circle that intersects the circle in exactly one point. And that one point will always be on the outside of the circle. It's called a tangent line, or tangent. So in example 1, we have to tell whatever they give us what it is. So they start with BC. So BC right here, that would be a radius. EA, so EA, so that's this line right here. So that's a secant. So I'm trying to give you guys time to answer these on your own, but if you don't know what it is, you can just follow along. DE, so going from D to E, be this green line here, touches the circle one time on the outside, so hopefully you can see that that is a tangent. Next is AB, so A to B, hopefully you can see that yellow there. So it has two endpoints on the circle and it goes through the center, that would be a diameter. Yeah, I think you can read that. And then finally, AG, so going from A to G, it does not go outside of the circle, doesn't go through the center, so that is a chord. So there's some vocabulary. All right, so here's a little theorem that we have. So if we have a circle, we got a point out here, let's call it point S for this example. So point S, we have a line segment that goes, or it's a tangent because it touches the circle in only one spot here. Then another tangent line that touches the circle in only one spot out here. What this theorem says is that these two line segments have to be congruent. So RS and TS have to be the same length. So we're going to use that theorem on the next page when we do example 2. So we got point R out here. They tell us that RS, so RS right here, is tangent to the circle C. And then RT is also tangent to circle C. So we got a point out here where two tangent lines are connected to it. So that means that these two blue tangent lines have to be congruent to each other. So 3x plus 4 has to be the same or equal to 28. So we just solve for x, so 3x is going to equal 24. So x will equal 8 after you divide both sides by 3. And that's what they asked us to do, find the value of x. Then example 3. Again, we have to find the value of x. So we got a point out here. These two lines are tangent. The reason I know they are tangent, since they don't tell me, is that we have 90-degree angles formed by a radius and the line. So that means that these have to be tangent. Since these two lines are tangent, they have to be equal to each other or congruent. So x squared is going to equal 9 when you take the square root of each side. X equals plus or minus 3. So x could equal -3 or +3. And then another theorem that we have. So if we got, well, this is kind of what I was just talking about in that last example. So if we got a tangent line and a radius, then a tangent line and a radius will always form a 90-degree angle. They will always be perpendicular to each other. So if we know this is a radius and we know this is a 90-degree angle, then that tells us this has to be a tangent line. So in example 4, it is DE tangent to circle C. So DE, this line right here, is a tangent to the circle. Well, here's our radius. And this does not form, let's use a different color. This does not form a 90-degree angle right there. So that would mean no. DE is not tangent to circle C. So this symbol just means circle. So that's how you call it. That's how they're labeling the circle. So circle C. Because this blue angle right here is not a 90-degree angle. Now, if you look to the right, this is a tangent line, PM is a tangent line. Because it is perpendicular, actually, let's write it like this, PM is perpendicular to QP. So the two gray lines, which now are going to turn black, those two lines are perpendicular, and this is a radius. QP is a radius, so since it's perpendicular to another line outside of the circle, it has to be tangent. All right, so last example here, example 5. We got to find the perimeter of the triangle. So I got a point right here, going to this point, going to this point. So those are two tangent lines. So that means these two purple lines have to be the same. If this is 3, this has to be 3 also. Let's use orange. So I got a point out here and another pair of tangent lines. Tangent line there, tangent line there. So if this orange line's 10, what would this one have to be? Hopefully you're answering 10. And then we got another point out here with two tangent lines attached. So if this green one's 13, this green one has to be 13 as well. So to find the perimeter, we just add up the lengths of the three sides, since it's a triangle. So 10 plus 3 plus 3 plus 13 plus 13 plus 10. So let's see, 16, 29, 42, 52. So 52 centimeters is what I got for the perimeter. And that's going to be it for the notes.